Hi everyone. Last section then, video-wise, on C4 vectors, and then you're kind of on your own. So vector line equations, intersections, we've dealt with that. And now we're going to be working with the dot product. So that really should say, dot product. Okay, let's do that. So what is it and what does it tell us? Well, like I said on the previous video, we are going to go into a lot of detail into what it is about, the dot product, and where it comes from, and you're going to prove it. But really, just to give you a sense of what it is, let's say you've got x dot y. Now this dot, this is a big chunky dot. This goes between, in the middle of your letters. If you see x dot y, that's like the Americans use it all the time for multiplication. So 1 dot 2 dot 3, that means 1 times 2 times 3. That was actually used in the exam once, and it freaked some people out, so that's why I'm talking about it. But I just think it's a bit silly, because if I see that, I'm going to think 1.2. How do I know that that's, really 1.2, the decimal place is in the middle, but, is that a dot? Well, you need to think about context of mathematical situation. So it's a fat dot for us, okay? And what is the formula? I'm just going to give it to you straight away. So x big dot y is the same as, and this is if x was, I don't know, a, b, c, right? And y was d, e, f as their vector elements, then x dot y is going to equal top element times top element. So a times d plus b times e plus c times f. Do you see? So top times top, middle times middle, plus bottom times bottom, and it's always plus. Okay, unless if b was -1, then it's going to be minus e. Do you see? So this is called the dot product, and as this is a number, can you see also why this would be called the scalar product as well? So the dot product is also called the scalar product. If they use that terminology, you know what it means, and that's because the dot product produces a number. There's a second definition for the dot product though, and the definition says that you have the magnitudes, so mod x times mod y, and then cos, the angle between them, so cos theta. So this theta here is the angle between the vectors. Okay, and we're going to talk about how that works in class. What is the dot product really? And I'm just going to say this phrase now. This is x dot y. What does that mean in real life terms? Well, it means x, the vector x projected onto y, on the vector y. So if you imagine, here's a vector x, here's a vector y, right? If I project x onto y, it's going to form, imagine that there's a light. So let's say this like this. Yeah, so just keep it simple, there's an origin there. Imagine this is in 3D space, and I grab a light bulb, a lamp like that, yeah, and the rays of light go onto x, okay? Therefore, that vector, its shadow, is projected onto y. Do you see? It's projected onto y. How can there be an angle between them? Well, you need to imagine it's projected onto y, but this is in 3D space. So actually, if this was in 3D space, let's say that x is all the way over here, its shadow may fall here. Do you see? So if y was a flat surface, here's the projection of x, and therefore, can you see here is our angle between the two vectors? That's what we're talking about in engineering. If you're interested in engineering, that is, this is used a hell of a lot, actually. And there's much more advanced things than this that you would learn if you were studying FP3. So this theta, this angle between vectors, this is the angle between vectors in the same plane. Do you see the same flat surface? So once this is projected onto the floor, this is the flat surface that contains x and y. So x is projection and y. And therefore, that's how you get the angle between them. More of that in class because we're going to do some bits with string to kind of show visually how this works. So in other words, what's the dot product for? Really, for us, it's to tell us the angle between vectors, and we're going to use it to find the angle between lines. Okay? Now there are some properties here, of course, because what does this tell us about parallel vectors? If two vectors are parallel, using the formula, so if x and y were parallel, that's what that sign means, then can you see if they're parallel, x and y like that, they essentially, if they're parallel, they essentially fall on top of each other, don't they, if they're parallel? Doesn't matter if they're equal lengths or not. And therefore, x dot y will equal, looking at the definition, mod x, mod y, cos theta. What's the angle between them? If it's cos theta, can you see if you put them on top of each other, there's x and y, the angle between them is 0, isn't it? And you know that cos 0 is 1. So if x and y parallel, x dot y is just going to equal mod x mod y. Likewise, if x and y were perpendicular to each other, you can see that x dot y is going to be the same as mod x mod y cos, and this time if that's x, that's y, 90 degrees, cos 90, and cos 90 is 0. So this is a very important property. If perpendicular, the dot product is always 0, and that's going to be a big hint for you to solve problems. So if perpendicular, dot product is always 0. Okay, so let's just do some basic stuff. So first off, it says find a dot b. So if a is 8 minus 5 minus 4, and b is 5, 4, minus 1, so straight into column vectors, a dot b, we know a dot b is either top elements times top elements, middle times middle plus bottom times bottom, or it gives you the angle, you see. So a dot b is going to be, you can write it as 8 minus 5 minus 4 dot 5, 4 minus 1 if you want, and therefore top times top is 40 plus middle times middle is minus 20 plus minus 4 times minus 1 is 4. So therefore we get 40 minus 20, that's 20, plus 4 is 24. So the dot product is 24. Part B. Part B says find the acute angle between A and B in degrees. So if this was A and this was B and this was an origin, let's say if you projected the image of A onto B, what would that angle be? Well, this is obviously going to need our second definition of the dot product. So you really need to know your dot product definitions. So whatever two vectors you're dot producting, it's their magnitude times each other times cos theta. And as we know, that's top element times top element plus middle times middle. So we already know that A dot B is 24, right? And equals mod A. Now what is mod A? We already know that the magnitude of a vector is the square root of its top element squared, middle, bottom. And same with B. So 5 squared plus 4 squared plus minus 1 squared cos theta. Yeah? So therefore cos theta is going to be 24 divided by square root. Let's get this going. So 8 squared plus 25 plus 16, so that's 105 on the bottom there, and also our b magnitude, so that's 25 plus 16 plus 1, so that's 42. So therefore, theta is cos to the minus 1 of that, 24 divided by root 105 root 42, and cos to the minus 1 of that gives you 68.8 degrees. Now notice the question said find the acute angle between A and B in degrees. Why is that? Let's think about that. Why does it need to make that distinction? Well, think about two vectors, A and B, right? Let's draw it as two lines even. So let's say this was A and this was B. Can you see that if two vectors are crossing each other, or if I just extended those two vectors like that, right? Can you see? But it's probably better if you look at it this way. This was that angle theta, but with every single, whenever you cross two lines, there's two angles between them, isn't there? There's a larger angle here. So there is a distinction. There's a small angle and there's a large angle between any two intersecting lines. So that's why it says acute. So therefore, cos when cos is positive, you're going to get an acute angle, aren't you? If you know anything about cast or silly tom cats or the graph even, you can see that cos is always positive between 0 and 90, and that's your acute angle, isn't it? So if your dot product divided by its magnitude is positive, you're going to get an acute angle. So really, if this whole answer was negative, you would get a non-acute angle, you get a reflex angle or an obtuse, right? So if we want acute, we need to always take the magnitude of our dot product. So cos theta is x dot y over mod x mod y. Okay? Which is just that formula but with mod signs next to it. So in other words, just always be aware that if it says acute, you need to take the positive. Second example, and there's three really important examples here. So, refer to a fixed origin O, the points A and B have position vectors this and this. Find the equation of L1. Okay, so normal stuff here, isn't it? So A is 1, 2, minus 3, sorted. B is 5, minus 3, and 0k, yeah? L1, so that's our R1, should be getting used to this now. So A plus lambda A to B, which is B minus A, so 5 minus 1, minus 5, and 3. There's R1. Done. Part B, the line L2 has equation this, so R2 is this, 4 minus 4, 3, plus mu, 1 minus 2, 2. Show that A lies on L2. Well, if A on L2, therefore A must be a point on the line. So if A is a point on the line, then R is any point on the line, isn't it? So 4 plus mu minus 4 minus 2 mu, putting that in together. Now if A does line on L2, then the mu's got to be the same, doesn't it? The mu has to be consistent throughout because it's timesing everything. So if it's inconsistent, A can't lie on L2. So from the top, I can see that 1 equals 4 plus mu, so therefore mu must be minus 3. From the middle, I can see if I move that minus 4 over, I get 6 is minus 2 mu, so therefore mu must be minus 3. And finally, on this last one, you can also see that mu is minus 3, therefore A on L2. Yeah? So that tells me something. That tells me that the lines intersect, surely, because if A is on line 1 and on line 2, then they must intersect the two lines. It says find the acute angle between the lines L1 and L2. So this is really important that you understand. And this is the my main beef with students when it comes to vectors. not understanding what's going on. And that's the difference between your first year and second year. So if you've got L1, there's the line L1, and you've got the line L2, you know that they cross at A, don't you? They're on both lines. You've just proved that. We want to find the angle between the lines. Look at my diagram. My diagram is comparing these two lines here. This is the angle I want, isn't it? And therefore, what are these vectors that I've just drawn on here? Are they A and B? No. If this is B, that's that vector A, isn't it? And this is the vector B, and this is the origin. I'm not comparing the angle here, am I? I'm not comparing the vector between A and B, the angle between A and B. I'm comparing the angle between the lines. And the lines are actually constructed of, I hope you're screaming at the video, the direction vectors. The direction vectors is what tells me um, is the angle that I'm looking for, right? So I'm saying d1 dot d2 then, back to your dot product stuff, is your mod d1, mod d2, cos theta, and theta is the thing that we're looking for. Remember, if we were looking for the acute angle, I need to rearrange this and mod everything because it says acute. So d1 dot d2 over mod d1 mod d2. So if we just extend this down here a bit, cut that off. So carry on down here. So cos theta equals, what is d1 and what is d2? d1, as you know, is the direction vector. So that's this one, 4, minus 5, and 3 for L1. And this one for L2, so 1, minus 2, and 2. And we also need the magnitude. So we know that's 4 squared plus minus 5 squared plus 3 squared, square root 1 squared plus minus 2 squared plus 2 squared. Do you see? How do you do the dot product? You know it's top times top, middle times middle. So that's 4 plus 10 plus 6. Do you see? Minus 5 times minus 2 is 10. All over. And let's go for it. So 4 squared, 16, plus 25 plus 9. So that's root 50. And 1 plus 4 plus 4 is root 9. Hopefully I haven't made any mistakes, and therefore theta is going to be cos the minus 1. That positive value is positive anyway, so it doesn't matter. So 4 plus 10 plus 6 is 20 over root 50, whoops, root 50, root 9. Let's go back and that should sort it out. And therefore that's going to be, so 20 divided by root 50, root 9, cos minus 1 the answer, so 19.5 degrees to 360, or to 1 dp. Okay? Now, that's taken us up to the point, the answer for C. Part D, because we've got another example here, we're going to do the other example in class, I suppose. Let's do this part D. So part D says position the vector C, the point C has position vector 2i minus 1 and lies on L2. So L2 is here, and C, don't know if I'm accurate with my diagram, but it really doesn't matter. Find the shortest distance from L to the line, from C, sorry, to the line L1. I hope you can see what's going on here. If I want to find the shortest distance from that point C to L1, then I need to construct a right angled triangle. Can you see? I always want the perpendicular distance from the point to the line. Notice that the right angle is not here. If it was there, then it's going to give a longer distance. I want the shortest distance possible. So my right angle is here, so perpendicular. Well, let's make it there then, right? perpendicular because we want to find the shortest distance to the line L1. We already know what that value of C is, and we know what A is, don't we? So can you see we've got a triangle here. We know a hypotenuse, and we know the angle, which because we just found it here. So therefore, we've got a triangle like this. All we need is the length hypotenuse, but because we know what A to C is, can you see we can now find the magnitude of A to C? A to C is C minus A, and C, as the question told us, was 2, 0, minus 1, minus an A we know is 1, 2, minus 3. So therefore this is the magnitude of 2 minus 1, that's 1, 0 minus 2 is minus 2, minus 1 minus 3, that gives us 2, and therefore that is the square root of 1 plus 4 plus 4, which is 3, isn't it? Square root of 9. So that hypotenuse is 3. We know the angle is 19.5. We're trying to find the shortest distance, x. So we should be saying sine 19.5, sorry, sine 19.5 is that opposite over that hypotenuse, and therefore x is 3 sine 19.5. And we're done. We should give our answer though. 3 sine 19.5, so that's 1.00 to 3SF. Okay? Alright.